Alright, so today we are talking about our first triangle center. Yay! Or not yay, you know, whatever you feel. Alright, so we got to talk about the perpendicular bisector theorem first, because you would have learned this last year. Okay, perpendicular bisector theorem, it says, if a point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment, in other words, it's saying this. It's saying, if a dot exists on the line that's drawn through the center straight up and down, that dot, no matter where it is, will be the same distance from the ends. So like if I do a dot up here, that'll be the same distance from the ends. So this will be the same as this. These two are the same. If I do a point here, these two are the same. Okay, that's all it's saying. Okay. How you feel about that? Hopefully okay. Alright, the converse says the exact opposite. It says, hey, if a point exists that is the same distance from both ends, then that point is on the perpendicular bisector. If I draw a line between that point directly down to the line that it's equidistant from its ends, then that point is on the perpendicular bisector. It's kind of cool. Alright. So, right here it says, what is the length of QR? So right now, we know that this is the perpendicular bisector. I know that because it's perpendicular and it cuts the line in half. If I know it's the perpendicular bisector, I'm using the theorem, not the converse. And I'm saying, hey, if those are equal, then these two must also be equal if it's a perpendicular bisector. So then we have 3n minus 1 equals 5n minus 7. So then I get all my n's on one side. I have negative 1 equals 2n minus 7. We add the 1 to both sides. We add the 7 to both sides. I get 2n equals 6. I divide both sides by 2, and I get n equals 3. Ta-da! That's the length of n. Did I find the length of QR? I have not. So I need to take 3 and plug it in. So we've got 5 times 3 minus 7. This is 15 minus 7. And 15 minus 7 is 8. So that length of that line is 8. Okay? I want you now to do the same kind of thing here. It says, what's the relationship between MB and JK? It's probably something we've talked about. Okay, and then once you know that, find the length of JM using that same process that we just did. Okay, and then we'll come back together. You've got that problem. Then you've got this one. So you've got a map of Manhattan, and it's saying, is the hospital equidistant from the nursery school and the legacy school, and how do you know? So I'd probably draw lines all over this, do all sorts of stuff. It's probably going to be something about what we're talking about. Then we'll meet back together to talk about concurrent and points of concurrency.